at another method of factoring or solving polynomials called completing the square. So before we get into what completing the square actually looks like, let's take a look at a couple perfect square trinomials as review. So remember, when you have perfect square trinomials, the main identifier between the two different formulas that we use is whether you are adding or subtracting your b value. So remember, if you're adding your b value, our two factors are a plus b squared, and if you are subtracting your b value, we have a minus b squared as our factors. So since in example A, we are adding our b value, we will use the first of our perfect square trinomial factors. So let's start by identifying our a and b values. Our a value in this case would be the square root of x squared, which is just x. And our b value would be the square root of 81, which is just 9. So using our formula, our first example here would factor to x plus 9 squared. Okay, very similar process for example B here. Remember, since we are subtracting our b value, we are going to use our second equation here. Our a value is the square root of our first term, which would just be x, and our b value is the square root of our c value, which would just be 8. So using our second form, that would give us x minus 8 squared. Okay? With all of these perfect square trinomials, it's important to remember that we can also factor these using our typical factoring methods. Yet, if you were to use, like our guess and check or AC method or Holen's method, either way, when you would factor this, you would get a result of like x plus 9 times x plus 9, which is the same thing as what we get using our shortcut for perfect square trinomials. So, scrolling down here, find the value of c that makes the expression a perfect square trinomial. You can do this by taking half of b, then squaring the value. Okay, this is essentially what completing the square is. So we aren't given a c value here, but to find that, we know that c equals our b value, which is 14, divided by 2. So taking half of b, then squaring it. Square. So half of 14 is 7. So we've got 7 squared, which just equals 49. So if we were to complete our perfect square trinomial, that would leave us with x squared plus 14x plus 49, which can be factored the same way as the examples above, as x plus 7 squared. Okay, on to example 2. We'll use the same process. So c equals half of b squared, which just equals 6 squared, which ultimately gives us 36. So our trinomial here will be a squared plus 12a plus 36, which would just factor to, not x this time, we have a plus 6 squared. All right, so both of those starting examples segues nicely into what completing the square actually is. So for completing the square, we first have to, let's just go over the steps here. So the coefficient of the quadratic must be 1. Okay, so your leading coefficient must be 1. Divide each side by a if it's something other than 1. Okay, so we can simplify our entire trinomial so that we have a leading coefficient of 1. We need to isolate the constant, so move the constant to the other side. that will create a perfect square trinomial, just like the one above, where we do not have a c value. Then we'll find our c value, like we did above, to balance the equation, allowing us to factor and then solve for x from there. Okay, so these steps, I even find this quite confusing. So let's just go through an example here. So first step here, we need to make sure that we have an a value of 1. In this case, we do. Then we need to isolate the constant. So to isolate the constant, we need to move 3 to the other side. So we'll do that by subtraction. That leaves us with x squared minus 10x. Now we have a blank here, equals negative 13. Okay, so for completing the square, we're going to use the same method as above to fill in a c value for what would be our trinomial on the left side. So in order to complete the square, x squared minus 10x, we are going to take half of our b value. So we are going to take negative 10 divided by 2, and we are going to square it, and that will equal negative 13 plus our same result. Okay, many of you will kind of skip this step and just do it in your head. Negative 10 divided by 2 gives us negative 5. Squared gives us 25. So this would simplify as x squared minus 10x plus 25 equals negative 13 plus 25. Okay, we can go ahead. Let's factor our left side, and let's simplify our right side. So to factor this, our a value is just x, and our c value, our b value, in this case, when factoring, would be 5. So my left side factors to be x minus 5 squared, which would equal negative 13 plus 25, which is just 12. So finally, we need to solve with the first step being taking the square root of both sides. Remember, when we take the square root, you need to have a plus or minus. So let's take the square root of both sides, which will leave me with x minus 5 equals plus or minus the square root of 12. Okay, after this, I am going to isolate my x by adding 5 to both sides. And at the same time, I'm also going to simplify my radical. So this gives me x equals 5 plus or minus. We can simplify the square root of 12 to be 2 square roots of 3. Okay? Since my result here has plus or minus, that acts as both of my zeros for my quadratic. Okay? So this is both of my solutions right there. All right. Let's take a look at, we'll do one more example for now. Let's do number 6. Number 5. Actually, we'll do both. So for number 5, we have our b value on the left side. So we must move that, b value on our right side. So let's move that to the left side. And simultaneously, let's move our c value to the right side. So that gives me x squared minus 14x, leave a blank, equals negative 19. Okay? From here, I'm going to take half of my b value, so negative 14 divided by 2, which gives me negative 7, and square it. And that's going to give me 49 as my new c value. So x squared minus 14x plus 49 equals negative 19 plus 49. Okay, from here, I'll factor my left side. This factors to x minus 7 squared. And my right side simplifies to positive 30. From here, take the square root of both sides, which leaves me with x minus 7 equals plus or minus the square root of 30. Okay, we cannot simplify the square root of 30. So all that's left is to add 7 to both sides, which leaves me with x equals 7 plus or minus the square root of 30. Okay, I know I went through that process pretty quickly. It's just so you guys can see what happens when your trinomial isn't in standard form when you are starting. All right, let's take a look at number 6. So for number 6, you notice that our a value is not 1 right away. So like our steps say above, let's divide everything by our a value so that our a value is now 1. So once I divide everything by 3, let's go ahead and simplify. That gives us x squared minus 4x plus 9 equals 0. Once I'm here, now I have a standard form trinomial. I can go ahead and solve. So start by subtracting 9 to the other side. That gives me x squared minus 4x, leave a blank, equals negative 9. To fill in my blank, I'm going to divide my b value by 2. So negative 4 divided by 2, which gives me negative 2. Negative 2 squared gives me positive 4. So that gives me x squared minus 4x plus 4 equals negative 9 plus 4. So to factor my left side, my a value would be x, my b value would be 2. So using my perfect square trinomial, that gives me x minus 2 squared equals negative 5. So now I'm going to take the square root of both sides. That gives me x minus 2 equals plus or minus the square root of negative 5. Okay, remember, anytime we have the square root of a negative number, we need to simplify it using our imaginary number. So let's do that as well as add 2 to both sides. So this leaves me with x equals 2 plus or minus. Since we have a negative here, let's put our imaginary number out in front. Give me I square root of 5. That way I do not have a negative under my radical. All right, so in order to keep the video somewhat short, I know I went through the algebra steps fairly quickly, but hopefully you guys were able to pick up with the general concept. So for class, we will go over 7 and 8 as a large group, and then I would like you guys to try 9 and 10 on your own. All right, thanks for watching.